We can authenticate OSPFv3, no surprises. And we can do that with SHA-1 or MD5. We'd choose SHA-1. It's going to give us a better level of protection. Like all other routing protocols, we are preventing or reducing the likelihood of getting rogue routes. Imagine default information originate being used to inject a default route into our autonomous system from a rogue router. And this really controls your administrative domain. Your autonomous system is now, if you use this properly, going to consist just of your routers and no one else. So you can see that IPsec is coming to the rescue here, and IPsec plays an increasingly larger role in IPv6. And we can see authentication header and ESP coming into play. Really, ESP is going to give us that ability to hide information, but authentication header is fantastic when we're just validating that the information is legitimate. There are two ingredients to get this to work. We configure the key, and we configure an index value. So we'll just be putting in an index value like 300. Won't really matter too much. Let's see a configuration, and you're going to be shocked at how short and concise this is. Now you can see that there's two different examples for the same thing. Area-based authentication, which really isn't area-based. It is interface-based for all of the interfaces on this router in that area. Don't do it that way. Do it in interface configuration mode, even if it takes you some extra time to do it. So we go into interface configuration mode, IP OSPF authentication. Notice it's only one command, by the way. We don't have to set the mode and then the key. We say, I want to run IPsec. My SPI is 300. I want to use SHA-1 instead of MD5. And then I'm going to put in a very long hexadecimal value. Get this working on both sides, and you're going to have neighborship up and running. Let's work with this in our environment to get a little bit more confidence. Okay, so I'm on R4. I'm going to go into my interface between these. Validate that I have an OSPF neighbor. And I do. Good, good, good. Dead time should reset at around the 30-second mark. Good. So we can see that. We might want to watch that. Now I'm going to do IPv6, OSPF authentication. I don't have to memorize this stuff. You don't have to memorize it either. Just context-sensitive help. SHA-1. And then we have to say, hey, I'm not giving you an encrypted key. And then, whoa, I got to write it in 40 characters. How am I going to do that? Well, I've got 32 characters in my clipboard. I'm going to do 8 more. 5, 6, 7, 8. Okay, so let's watch our neighborship drop. This shouldn't go down below 30 unless we're starting to lose packets. And we're losing packets because we're throwing out packets that look invalid to us because they lack the authentication credentials. The other side doesn't have authentication yet. Okay, so we're going to watch this neighborship come crashing down. Good. We must break it to reform it. And I'm going to just copy and paste this now. It's kind of a long command, right? So copy and paste. Not surprisingly, we got our neighborship drop. Loading full. Look at that. So my neighborship came back up. we are looking good. So that's how you set up authentication for OSPFv3. It's maybe a little bit more typing, as we can see here. That's a pretty long key, but it's all in one command, which, boy, anytime we can do something complex in a single command, I mean, IPsec. We don't want to have to do some big old IPsec configuration. I mean, IPsec configs get really out of hand. And so we are shielded from a lot of the ingredients, and that is a very good thing.